want to continue with the chapter on the storage visualization basics. Actually, this is we are not continuing. This is like the first time we are introducing this chapter. We actually stopped in chapter 3 before, so this is a new chapter, storage visualization basics. In cloud computing, one of the most important aspects of cloud is the ability to store information uh, in the clouds. And this storage services is provided to the users on demand. And users can store information on the cloud for a very long time. And of course, they can be able to restore information from the cloud anytime there's need for a disaster recovery to take place. So the cloud service basically helps the users to store information somewhere out of the physical device they use. In case if there is any disaster that happened to their device and they may need to change the device, it means that it will be easy for them to be able to recover their information because the information is not actually residing on their physical device, rather is stored in the cloud. So now we want to look at the basics of how cloud actually is able to achieve this very important function. That is the essence of this chapter. So to start with, data has become an enterprise, which is important asset, very important asset to any organization. And how is data stored in the cloud is what we are going to look at in this chapter. How is this different from the way it is stored in traditional IT environments like our physical devices? This is another important thing we are going to look at. So this chapter will try to answer these questions and many more as we proceed into the chapter, inshallah. So the objectives of the chapter. So upon completion of this course, you are expected to be able to understand how Huawei's Fusion Sphere visualization solution works and understand the storage architecture used for visualized environments. Also understand the different types of disk, understand the differences between centralized and distributed storage services, which cloud actually provides. We hope also to be able to understand the differences between visualized and non-visualized storage. Also, to understand the different types of virtual machine disk. Last but not the least, we hope to understand the storage features of Huawei's visualization products. So let's go through it together and see how this works. The content of the chapter is divided into 6. In the first section, we will discuss about storage architecture for visualization. In the second chapter, we will discuss about physical disk types and related techniques. And of course, as mentioned in the objectives, we will discuss about centralized storage and distributed storage of cloud service. Section 4, we will discuss about visualized storage and non-visualized storage. Then we will introduce virtual machine disk in section 5. And last but not the least, we will discuss about storage features of Huawei's visualization products. So as normally the slides are arranged in such a way that Huawei will always describe for you the general technology of whatever they are going to introduce. And then in the last section, they will introduce to you how their own product works. So basically, first, section 1, 2, 3, 4, and 5 are general ideas of how the technology of storage in the cloud works, while section 6 is more specific to the product of Huawei, which is the last section. So they will tell us how they achieve cloud storage services using virtualization and what are the products they have. So basically, this is how they normally arrange their slides. So for today's class, I hope that I will be able to cover at least the first three sections. Okay, the architecture of visualization, storage architecture, physical disk types and related techniques, centralized storage and distributed storage. And of course, maybe in the next class, we will take on the next 4, 5, and 6 sections. I think this is the first time I'm going to divide the slides into two. So where do storage resources used by virtual machines come from? Virtual machines run on the cloud. We know that they are managed by hypervisors or virtual machines monitors, or what is called virtual machine managers. However, the storage resources used by these virtual machines, where are they coming from? This is another important thing that we need to discuss. Okay, so, but in traditional IT environment, we know about the SSD. SSD is a type of what? Disk, right? It's a type of disk. And of course, we know about HDD, the hard disk. Okay, and we know about so many other technology that are used for storage. So as we continue in this chapter, we will see how these technologies actually helps to provide storage services in the cloud. So let's look at the general storage architecture for visualization in the cloud environment. Starting with visualized storage. So the storage architecture is divided into two actually, the visualized storage and the non-visualized storage. For visualized storage, it always has to start with the physical device. In this case, the physical storage device. So at the lowest level, okay, we have the physical storage device. So immediately after the physical storage device, that's where we have pull-up storage. So what do we have in the physical storage device? This is where we actually have the disk that contains the information. Of course, the disk can have, we can have actually different types of disk, okay? So all disks that contains also are used to store information connected together using a certain technology, whether we are using replication technology or we are using the RAID device technology. This will help to provide a pool of storage services. Okay, so in this second section, you will see that immediately after the lowest section, the next level is where we have the pool of storage services. So the pool of storage services have also two technologies that can be used to drive it, which is called the SAN storage. And of course, the other one is called the NAS storage. The SAN storage is it's a situation whereby you have a pool of resources. These resources are connected to a server, and then users basically access information from it. Then in the NAS, we have different devices, heterogeneous devices. and users uses the network to access information from it or to simply store information from it. So for the SAN storage, it uses logical division of the disk, while for the NAS storage, it uses file system. Okay, so basically, for the logical division of the disk, immediately after the SAN storage, we can have a logical division or a logical volume of the information, and then file system. We have different type of file system. It can be a FAT or the new technology file system, which is called an NST, new technology, NTSF. Yeah, NTSF. So immediately after that, that's when we can have the shared catalog of resources of storage information, in which we can have different types of information stored on it, on the visualized storage information system that the cloud is using. So basically, the users of cloud services, they have interaction with this section, which is the shared pool of catalogs that we have to store files and store information, okay, on the cloud service. So that's how the visualized section looks like. For the non-visualized section, almost similar, except that in the non-visualized section, after we have the physical devices, that's the storage devices, basically. It can be the SAS, or it can be the part which was used before, okay? Or it can be any type of physical uh, device that is used for storage. So immediately after that, we can have a logical division that contain distributed storage pools of spaces that can be accessed by the users. And of course, in this case, we do not have the SAN or the NAS storage application to run it. It simply provides the shared pool of resources or space to the users. So this is how the non-visualized storage networks actually works in the cloud service. So there is some little differences. For the visualize, it uses the NAS or the SAN basically to manage the physical resources at the lowest level. Also at the lowest level here for the non-visualize, we have similar physical storage devices that are used by uh, that are used to create storage pool, basically. And this storage pool is mostly a logical division of the storage space that is there in the physical storage device. And this logical division will simply be given to the users to access and store information um, in the cloud. So these are the two different types of the architecture that can be used in the cloud for storage architecture.
Doctor, what is the shared catalog? What does that mean, this part?
Very good. The shared catalog basically is the space where users can actually store different types of files. So if you check up there, you will see different types of information in there. Okay, QCOW, raw information, VMDK information, VMHD information, and other information. Basically, what we are saying here is the shared catalog is that space that the cloud users can interact with to store information. So once this is stored, information is stored here. Of course, the information will have to go through these various stages to the lowest level, which is the physical storage device, and it will be stored in there. But for interaction of users, the users mostly always actually interact with the shared catalog.
Okay, so it's like the resources, yes, that you use, or what is a QCWO?
Oh, QCWR actually is a type of information that can be stored. Okay, so they are only trying to give example of different type
Like
of
the
information.
extension, or like extension
Yes,
of the type of information, like
yes.
virtual machine or virtual disk or like this stuff.
Yeah, it's simply to say, for example, Word, Excel, videos,
Ah, okay,
uh,
okay,
you know.
okay. Like
So
the format of the storage type or
exactly.
storage
So
data, store data. Okay.
exactly. So just look at the type of icon that is used. The same type of icon that signifies that is an information. Okay. So you can see here it says others.
Yeah.
Any other information can as well be stored in the shared catalog, which will in turn be stored into the physical hard disk, basically. So let's go to, yeah. So I just try to, because the Huawei slide somehow is not very informative. It's mostly diagrammatic illustrations. So I just try to give you the full meaning of NAT, a network attached storage. And the SAN also means storage area network. That's the full meaning of this. If you want to see the explanation to it, also I put the explanation down in here. Though I did this just today, so I will need to upload also or update these slides for you on the Blackboard later with just additional information. So as we said, the shared catalog is basically where files are stored. Okay, so from the lowest level, we have the physical disk, and this physical disk uses two different types of technology, whether it uses a RAID technology or it uses what is called replication technology. We will explain this later in the slides, okay? But I want to believe that anyone that take the took with me forensic, you are already familiar with the term RAID technology, okay? So we're gonna see more of
Yes,
it.
doctor. Yeah.
Yeah, we're gonna see more of it and also replication technology. These are the two types of technology that the cloud service also use to combine and create pool of cloud service resources that becomes limitless and becomes illusionally unlimited to the users, basically. So with this physical devices, storage devices created using either RAID or replication, we can now have what is called a physical volume of the resources, basically, or the storage space. And then different types of file systems can be stored in it. So, but of course, the most recent file system that can actually be stored in the physical volume of the storage space is the NFS, which is new file systems. Then after that, we have the logical volume created, okay? And then the virtual file system is created, and then we have the catalog. So these are the different stages. But as I mentioned in the other slides also, the users always interact with the shared catalog and the resources are created at this level, but eventually they will be stored at the lowest level, which is the storage level. And that is why if you have problem with the shared catalog, it doesn't mean that your storage information is destroyed. No, actually, it's still available. All you need is to have another device to be able to log in back to the shared catalog, and you'll be able to have access to your resources that are stored at the physical level of the cloud. So this is how the visualized storage conversion part in cloud computing actually looks like. So always start with the physical level and then it goes up. So for the non-visualized storage conversion part in cloud computing, so basically what we are trying to do is to give additional information to what we explain here. Okay, so for this section, it's explained in the next slide. For this section is also explained again in the other slide, in this slide basically. So non-visualized. So also it uses either RAID or replication at the lowest level, and then it goes to create what we call physical volume and the logical volume, which are mostly clustered based on clustered computing. And then a pool of resources is created which can be used by the users. So in this case, we have only two additional steps after the storage space or the hard disk, which is at the lowest level. So that's all about the storage architecture, visualized and non-visualized, and how they look like. So let's go to the next section. Do we have Muhammad in the class now? How about Ali?
Uh, don't think so, Doctor.
Oh, okay.
Yeah, it's just me and you. Here. Speak of the devil, as we say.
No. I'm the one calling them actually. They didn't
Okay.
join me.
Okay. I thought
I'm
he's.
just trying. I'm just trying to call them. That's why you see the names.
Yeah.
Still did not join. Okay, so we'll continue because today actually I don't want to be more than 1 hour for this class. So that's why I want to take only first section and then we take the second section in the next class, inshallah. So let's go to
Yeah.
the
No
fiscal
problem,
types.
Doctor. Whatever you can I do today, we can do next also.
Yeah.
Next class.
So for the physical disk types and related techniques, the physical disk type, we have different types of disks actually. I want to believe you are familiar with the SATA. SATA disk. The SATA disk,
This is the normal hard drive.
yes. And it's connected using the what we call the SATA cable. Is somehow you will see it like I mean it's
The double cable, and you
yeah,
connect to
the
the power
double
supply.
cable is a bit
Something like
is
this.
wide. Yes. So this is the SATA disk basically. So this is one of the disk types. So let me go back one step at a time. So these are the type of disks actually that we have at the lowest level. Okay? Physical disk. So the SATA disk, the full meaning is Serial Advanced Technology Attachment. Sometimes it's simply called serial ATA, because before this, there used to be another one which is parallel. So they call that one parallel ATA. So after parallel ATA has some issues, okay, related to errors, okay, and how it corrects errors when it occurs. So therefore, it becomes a very non-reliable disk. Therefore, they now create serial. Okay, so you can see from the name, it's called either serial or parallel. So, but now, mostly we only talk about the SATA disk, which is the serial ATA. Okay, so I try to bring out the important information that you need to know about this. This serial ATA is it's very good in keeping embedded clock signals to check transmission commands and not only data, and also automatically it corrects detected errors. So this is like unlike what we used to have in the parallel ATA before, where errors that are that occurs in data storage cannot be corrected, therefore we lose a lot of information. The SATA can actually automatically correct detected errors and ensure reliability of data transmission for the data disk. So this is one of the most important feature. So, but another feature of the SATA disk is that the SATA disk is simple and the disks are what we call hot swappable, hot swappable. So please try to check what the full meaning of this is, hot swappable. But
I,
it's one of,
I know, I know, Doctor. It's the use of like it's easy to replace. Like you can just pull it out and put the other one, and like if one fails, just like pull one and put another one there.
Good.
Like it's
Yeah,
easy
to
to
swap.
change. Yeah, to
Yeah,
swap.
it's easy to swap. Okay, I get it. Okay, so we have the physical disk type, which is also called SAS. The SAS look like this. Okay, this full meaning of the SAS is called serial attached SCSI. Serial attached SCSI. So it's
This is the same
actually
as the
in,
SSD, yes?
no, this is not the SSD. We will discuss the SSD later.
Okay.
Uh, yeah. So this is actually a new generation type of technology, and it's very popular, as popular as the SATA also. The advantage is that as compared to the all parallel SCSI, this particular SAS improves the efficiency, availability, and scalability of storage systems, and it offers optional compatibility with SATA. So sometimes it can actually be compatible with SATA. The connection cable look like this. If you can see it on the screen, it look like this. A little bit different from what we have with the SATA that have that double type of cable basically. So this is how the connection cable look like on the SEA. So the physical disk type, we have another one which is a bit more advanced than the SES. This is called NLSES. It's a newer version of the SAL, which is nearline SAS. This type of disk is a combination of the SAS, but it has an interface of the SATA disk. So this is how it looks like. Okay, this is how it looks like from the back. The advantage is, um, however, with the SAS interface, addressing and speeds are improved. So they try to include both the features of the SAS, okay, and the features of the SAS together in order to improve the interface, the addressing, and the speed. So these are the things that they try to improve by creating the NL SAS. So this is the SSD that you mentioned earlier. The SSD is very good technology also. The full meaning is solid state storage device that uses integrated circuit which assembles as non-volatile memory. Non-volatile memory means what?
It doesn't delete when you close the computer.
Exactly. So non-volatile means that when you shut down the system, when you reboot the system again, you will still find your information. In a volatile memory, basically, once you shut down the system, you lose your information. So this SSD actually is very good, and an SSD consists of control unit and a storage unit like the flash drive or DRAM chips. Okay, and an SSD is also same as a common hard disk drive with like the HDD, which is the hard disk basically. The most important advantage of the SSD, it delivers fast read-write performance, okay, and it's lightweight, lower power consumption, compact size, which traditional SSD cannot actually rival. An SSD have a shorter lifespan and higher price. It's a bit expensive anyway, as compared to the traditional hard disk, which is the HDD basically. So this chart try to compare them in terms of performance actually. So the SATA, okay, in terms of performance and price, the SATA disk In terms of performance, it has a lower performance and it's lower price. Okay, and then followed by the SaaS. It has actually this, yeah, this is SaaS, of course. Maybe NLS, yeah, this is SaaS. Okay, it has a bit higher performance than the SATA and also a bit higher price than the NLS SaaS. It has also a bit higher performance than the normal SaaS and of course a bit more expensive. And then the SSD basically at the top level have higher performance and of course a bit more expensive or higher expensive, more expensive than all of them basically. So you need to check the level as it is. Let's say for this, we can do like this. In terms of performance, maybe this is where it is. In terms of price, this is where it is. Okay. This one in terms of performance, this is performance chart, and this is price chart. Also, this one in terms of performance and in terms of price. And of course, this
The
in
higher
terms
the
of
performance,
performance,
the higher the price.
exactly. But again, I'm trying to find out how to play around with this pen. Always I have to exit the slideshow before I can write. I don't know if there's another way. You know another way that you can use the pen from here without exiting the slideshow? If I put on the slideshow, I cannot use the pen. So if I remove the pen, if I remove the slideshow, yes, I can use the pen. I'm trying to figure out how it's done anyway. Let me see, is that
Uh, right click doctor and then marker, I think. You can do it
okay?
inside the slide.
And then
Marker, maybe.
okay, pen. I think there's a pen here. Oh yeah, I got it now. Yeah, it's very funny. Okay, I get it now. So how do I remove it now?
Same thing, I think, in reverse, maybe.
Previous. Okay. Uh, let's see. Erase. Good. So I got it. But it is actually better to play around with the rates like this than always have to go to the other side. Okay. So I go to the next slides now. Okay, so we go to the centralized storage and distributed storage, how cloud service handles these technologies. From the name centralized storage, it implies that the information is actually centralized somewhere, okay? And other users have to all go to the same point to be able to access the information, okay? So in the case of a centralized storage from the name, we have, of course, at the lowest level, we always have our disk, physical disk spaces. Okay, these physical disk spaces can be as many as possible, connected either through a RAID or through the other technology which we call replication. So if you look at the RAID here, basically, you can see that we have different servers that are connected uh, to the storage pool. And all these servers basically can read and they can write from the storage pool. The storage pool interact directly with the physical storage, which is connected using a RAID service. So what it implies is that all these other services or devices that are connected on the cloud, they can actually store and they can as well delete information on the cloud from a centralized storage pool. This is the centralized storage pool. So basically, they all connect here. They can read and write through it. However, the information that is being written or being deleted on the storage pool is eventually going to be stored or deleted also from the physical device. The physical device are connected using a shared pool of physical device also. So this is basically how it works. But we also know that the NAS and the SAN are used at the physical storage device to connect the RAID services or to connect the different physical devices. So we explained how it works for the NAS and also how it works for the SAN in the previous slides. So let's look at the RAID technology. Since we already mentioned that these shared physical devices are connected using a RAID tech. So a RAID tech is basically a connection of physical devices in order to create redundancy, as we explained in the other course. And we have different levels of RAID, starting from RAID 0 up to RAID 7 is the most important aspect of RAID. However, we can have different combination of the RAIDs. We have RAID 0, to RAID 7. And after that, we can have different combination of RAIDs. We can have, if you combine RAID 1 and RAID 0, you're gonna have RAID 10. If you combine RAID 1 and RAID 5, it will be RAID 15. If you combine, for example, RAID 1 and RAID 2, it will be RAID 12. So that's how it is actually. So let's come here and look at how RAID 0 looks like. RAID 0, for example, you have two physical disks. Okay, you have two physical disks. So what it implies here is, in this case, you have only two physical disks. If you have two physical disks connected using RAID 0, what it implies is it uses stripping technology. What it implies is that if this is 10 gig and this is another 10 gig, it will combine the two together and to give you 20 gig. So the logical disk will be 20 gig. However, because it goes through stripping, it also implies that the the data stored, okay, will be stored in two different logical disk spaces. So if you have a file that is 2 gig file. So 1 gig will be stored in one logical disk space, and the remaining 1 gig will also be stored in the other logical disk space. That's what it implies. So let me go back to my pen. So if, for example, one of the disks get crashed, it means that you're gonna lose all the half information that you have here. You will be left with only half of the information of that file. And half of the information of that file is not enough to be able to recover the file. So basically, redundancy is absent in this. No redundancy.
Yeah.
So
And
you
for
can,
the mirror also, you need like how many percent like of the data to like you be able to recover it.
oh,
For example,
for me,
with the parity, this one like rate 5, I think. Yeah, rate 5. Uh, like if you lose like one, can you like get the information and this parity is saved in all of them? Yes.
yeah, okay, so I will explain this later, but let's look at this.
Okay.
Actually, even in RAID 1, you can recover this, but in RAID 0, you cannot recover a file when one
Yes,
of the disks.
just is-
Yes, so because this is mirroring in RAID 1, it
yeah.
implies that if you have 2 gig file, 2 gig will be stored here, and the same 2 gig will be stored also here. Okay, so you have 2 here and you have 2 here.
Yeah.
So basically, this is meant for recovery. So if this get crashed, you still have your 2 gig here. So basically, this
It's
is good for,
redundancy mirrored. Okay.
yeah, this is good for redundancy. So for the parity check, it's very good technology also that is used. Just know that number one, any disk, RAID disk that want to apply parity check, it implies that you may need at least 3 or more physical disk. Okay, so that's why you see this physical disk at 3 here. So in the parity check, uh, RAID RAID 1 will have a parity check at level 2. RAID 2 will have a parity check at level 1, and RAID 3 will have a parity check at level 0. The most important aspect is this is RAID 5. They are trying to see how they can cope even when like more than one disk fail. So basically, if this fail and this fail, you'll be left with this. Okay. It implies that because parity check is used to compute missing information, you still have your parity check on disk. So therefore, it can only take longer time to recover the information, but the parity check can actually be able to reconstruct the file that is missing, even after the other disks are actually got crashed, basically. So also, this is another one, RAID 6. RAID 6. RAID 6 also have parity checks in each level. Okay. Basically in, let's say, in 2 levels. Okay. This level and this level. You have this and this. And here you have this and this. Here you have this and this. Here you have also this and this. So also here you can actually afford to have missing disks, and still you can have your redundancy on this. So this helps in redundancy. Also, this is good for redundancy plus security, actually. Redundancy plus security. This is actually very good for that. So these are the important things that we need to recall. Um, the other information related to other disk, the Huawei did not actually explain other disks like disk 2, disk 3, disk 4, but RAID 2, RAID 3, RAID 4, they simply jump to RAID 5 because they are expecting you to go and find information about this and know how this actually works. So these are the important ones that I mentioned in these slides. So let's look at the centralized storage type that uses the SAN and also uses the NAS. So you have the centralized storage device. For using SAN, it uses 2 different types of protocols, the IP SAN protocol and the FC SAN protocol. IP SAN is, of course, the one that's using the IP, okay, together with the SAN technology to give different servers access to a pool of resources that are stored in a physical device, okay? And this takes place using protocol, network protocol called IP-SAN or FC-SAN. Of course, IP-SAN is Internet Protocol SAN, and the FC-SAN is actually fiber, I think fiber optics. Let me see, sorry. Yeah, fiber channel basically. So it uses the fiber channel. I try to put this additional information as a footnote for the student to go through and read them during your studies. So this uses the fiber channels in order to use the network and access pool of resources or shared storage resources in a centralized environment in the cloud. For the NAS, also a similar information is there. So here is actually the pool of physical resources connected using the NAS technology. The NAS technology uses two types of information technology to share resources with different servers. So you can have one server here and another server here. And this is a client, this is a client. They may be using different types of operating system, like this is using Windows, another one is using Linux or Unix in this case, basically. And then the technology that connects the Unix technology that connects the server, okay, the Unix server with the cloud storage space, physical cloud storage space is actually NFS. Well, for the Windows, they use CIFS technology to connect between the Windows server and the NAS device. So these are the two different type of technologies that is used. So important things to remember in this case for the SAN, it uses two types of protocols, either IP protocol or the fiber channel protocol SAN. While for NAS, it uses the CIFS connect Windows servers, while it uses NFS to connect Unix servers. These are the technology basically. So,
Dr. NAS stands for what? Network assisted storage or
network attached storage.
attached storage, and SAN is storage attached
Storage
storage
area
area
network.
area network. Yeah.
Yes, storage area network, yes. So, for distributed storage, it's using what is called replication. So, as we mentioned earlier, in order to connect the physical storage devices that will be used for the cloud is using either the RAID technology or it uses replication technology. So far we only explained the RAID technology. Now we want to see how the distributed storage service is actually using the replication technology, okay, to provide cloud access, storage access to pool of resources to different servers. So we have different servers. The servers can read and write on the cloud. Okay, that means they can send information, okay, to a distributed network and to a distributed storage. And of course, they can delete also this information if they don't want. That's the read and write basically. Data read and data write. Another thing that we need to remember anytime we mention about distributed storage is that the physical storage devices are not stored in the same place. Okay, so they are actually stored in different locations, only connected through a network. Yeah, it's very important to remember this because even though the diagrams for the centralized and the distributed look the same, but actually the pool of resources that is used in a distributed environment, they are not connected. I mean, they are not physically in the same place, okay, like what we have for the RAID. Rather, they are actually distributed across the network, only connected using the network service. So that's why actually it's called distributed storage space. So for replication, because the disks are actually connected um, using replication, okay? So what happened here is if I have my file, I call my file A, okay? File A sent by, let's say, this server called server A. So if file A is sent here to the cloud for storage, this is what happened. File A will be replicated and it will be stored on one device, okay? And it will be stored here also in another device, and it will be stored in another device, physical device here. So if you can have this file here, you can have this file here. Good thing is they are not actually these devices, okay, these physical devices are only connected through the network, but they are actually distributed across. So they are not physically in the same place, basically. I hope I'm trying to be as clear as possible. So I hope this information is passed. So this is actually the essence of replication. In case if we have a problem with not one of the devices of the distributed storage pool, basically we can still replicate or we can still recover, okay, the file that we store in another device which is connected through the distributed replication system in the cloud. If this also got crashed, somehow we can get it somewhere. So the advantages of distributed storage, I tried to add this information also just now. It gives data storage. It's geographical distributed. It's geographic distribution. That is to say, geographically, they are not actually in the same place. They are distributed across different areas of the network. So that's why if one get crashed, you can actually get the file back or restore the file back from another different location. Also, it helps very good in synchronization. Synchronization mostly is basically to check the consistency of the file, basically. Uh, then also failover and disaster recovery. This type of storage device for cloud is also very good for disaster recovery and data protection. So these are some of the advantages I tried to put here. So
Thank you,
additional,
Doctor, for yeah. I just want to say thank you for adding like these notes because like when I try to study, I see that there is not a lot of explanation, just like a lot of diagrams and it
exactly,
doesn't like really explain like what they are trying to say or what they want us to learn or so
yeah,
it's better if we have yeah like at least like some slides to more explanation or more information.
exactly.
Thank you.
So let's go to the last part. More explanation related to application. Actually, this I already used the diagrams there to explain. So you have your data. If you write a data, it goes in, and this data will be replicated. Okay, that this is the same file actually. You can see this is the same file that it comes here, and then this file, when it goes into the distributed storage pool, it will be divided or replicated into three. okay, before it goes
There will
into
be
store.
synchronization, doctor, between them.
Yes, there has to be synchronization because they need to check for consistency of the file, So
Okay,
it can be stored
so this
in
is more
different
of
locations.
like backup or
Exactly, exactly. So it's very good for backups. Okay. So in terms of redundancy, this is excellent. So you can see the file is now stored here, is stored here, and also is stored here. Okay, this is for write. In terms of reading also, as I said, in case if one of the cloud's physical device fell, you can still get it from another physical device. Since they are geographically actually not located in the same place, unlike what we have in the physical devices are in the same system, except that they are connected through a RAID technology. Okay, so this is what this one means actually. So popular distributed storage products, these are the popular ones. Safe, hard up, HDFS. Okay, there's VMware, which is called vSAN. vSAN is also used for this type of distributed storage products, storage service in the cloud. But for Huawei, they use this one, Fusion Fusion Storage. This is for the Huawei. So basically, this is where I hope to stop for today. And that means we have covered how many slides? Let me see.